In this unit, we're going to begin the topic of linear regression. And to do this, we're going to start off with a real simple concept here. We're going to start off by looking at Celsius and Fahrenheit data. So if you remember back in your days of high school, let me open up this Excel spreadsheet here. If you remember your days in high school, you know that there's a conversion between the temperature in Celsius to the temperature in Fahrenheit. So you can see here that if it's 0 degrees Celsius, it's 32 degrees Fahrenheit. And if it's 100 degrees Celsius where water boils, it's 212 degrees Fahrenheit. And interestingly enough, the temperature of -40 in Celsius is the same temperature in Fahrenheit. So that information will probably get you a piece of pie if you play Trivial Pursuit. So that's an interesting trivial fact for you. Now let's go on and graph this guy. So when you graph these points, you can see that they graph to a very nice little straight line here. And in fact, we are going to add the line right here. So using Excel, I've already done it, so I'm going to click on this and you can see a nice, very pretty red line here. And all of the points fall directly on that line. And I can even go over here, and if I click on this line and say format the trend line, I can even display the equation, the mathematical equation, and the r-squared value. So let me do that. And Excel has now added a mathematical formula, which means that this red line, if you remember back on your days in high school, has a mathematical formula of 1.8 times the temperature in Celsius, because remember X was my temperature in Celsius. So 1.8 times the temperature in Celsius, and I add 32 to that, and I'm going to get the temperature in Fahrenheit. Now this r-squared value is equal to 1. Now what does that mean? Well, I'm going to come over here and make that a slightly larger, so I made it a little bit easier to see. And I've also clicked in here, and I've added 2 zeros and a percent because the r-squared is traditionally represented as a percentage. So what does a 100% r-squared mean? It means that 100% of the variation or change in the blue dots is described by this mathematical formula. That's possibly it's sort of an abstract concept if you're not an analytics person or not a statistician. So for a manager or a data person, think of the r-squared value as just simply how accurate is the model. If you have a 100%, you're going to guess that every one of your points falls on your line. If it's less than 100%, say 90%, these guys are not going to fall directly on this line. There's going to be they're going to be off a little bit, and we're going to look at some data like that later on. You're going to see that not 100% is not what you normally are going to get. However, in this case, we have a perfect model. We know exactly, if we know this is the temperature in Celsius, this is what it's going to be in Fahrenheit. This is a perfect model. Now, let's go over here, and remember we have this mathematical formula 1.8x plus 32. So let's come over here and just predict. Now this is what it is. So this is our temperature in Celsius, and this is our temperature in Fahrenheit. So let's just, for people, I'm assuming everyone is very familiar with Excel at this point. So what I'm going to do is I'm just going to type in a formula, equals, and then I'm going to say 1.8 times the temperature in Celsius plus 32 degrees. And you can see that these two numbers are exactly equal. And the error, this guy here, minus this guy, is 0. So it's perfect. So let's just copy this formula over here. And you can see if I have a -40, I want it to be -40, and I get an answer of -40. So again, 0 error. So I'll just come down here, and you can see that the mathematical formula works perfectly. So these are my predictions right here. I'm predicting it. This is what I want it. This is what I predict. And I have perfect accuracy because this is a trivial model. Now, with Excel, you are not limited to just simply graphing it and then coming over here and adding a trend line. That's real convenient when we have just two variables, one x and one y. Now I'm going to show you later on, we're going to look at a case when we have more variables. So using this in Excel, let's come over here. If you come up and click on the Data tab, and let's come over here and find some area in the ribbon here, and we're going to right click, and we are going to customize our ribbon. And then if you look over here and we hit add-ons, now way down here you want to find manage. And if you click on this, you have all sorts of different add-ons. And I'm not an Excel expert, so I don't know what a lot of these things do. But this is the one you want right here, Excel add-in. So click on that and hit go. And you see a lot of these boxes. Now some of you may have your this already enabled, but if you don't, I'm showing you how to enable this. So come over here, Analysis Toolpak, and we're going to click on that guy. And we're going to hit OK. Now you notice that we got this box up here. So what I'm going to do is we're going to click on Data Analysis. So we click on Data Analysis, and up comes this box, Data Analysis. Now what we want, there's all sorts of things we can do, but in this case we're going to click on Regression, which is already selected in this case, so we're going to hit OK. And up comes this box. Now I'm going to give you a safety tip here. I have learned that what you're going to want to do is first click on the output range, because when I click on some of these guys first, things sometimes it's kind of hard to unselect these boxes. So basically there's a little glitch here, so it still works, but this is the safest way to go. So click on the output range first, and let's click on this, and we're going to put all of our answers right here. So that's the box. So we click on that, and that's where our results are going to go. Now let's click on the Y value here. So the Y value is what we want to predict. So we click on this guy, and we want to predict the Fahrenheit. So we're going to also, we don't have to, but we're going to include the label here. The label in this case is Y. And let's go over here and come down here, and we're going to predict this is the X. So the X is what goes into the model. Now remember, we've also selected the X and the Y here, so we have to say we've got labels. So if I hit OK, look at what happens. Excel has now given me a regression equation. And the regression equation tells me that X, whatever my X is in this case, if I multiply it by 1.8 and then I add 32, that will give me a Y value. And if we remember, let's go back to our trend line right here, 1.8 plus 32. So this line, we can get this with our with the data analysis function up here. And the nice thing is we're going to be able to have more than one variable shortly. Now, at this point, I am tempted to go into the math behind this, but that's not really the scope of this class. The purpose of this class is to get an overview, an understanding of this, so that if you are managing a team of analytics people, you understand what they're talking about. Or if you're a data person and you're upstream from the analytics team, you will be able to understand what they're referring to. So we're not going to go into the math of how this is done, but I want to give you some things to understand. So the first thing is when you get a regression formula, what you're getting is this guy right here. You're getting the formula, the mathematical formula. So let me highlight these guys. So that's important. I got this mathematical formula. I'm going to take X, multiply it by 1.8, and I'm going to add 32. Now, some other stuff that you might want to, that you're going to hear when your analytics people are talking to you, you're also going to hear these guys right here. P-values. What's a p-value? A p-value is the probability that this variable is a bad variable. So this is, got to think of it the opposite way. So if the p-value is very low, the chances of it being a meaningless variable is very low. So if it's got a low p-value, it's good. So think of it this way. A low p-value means that it has a low probability of being bad. Meaning, and by bad I mean it doesn't belong in the model. Now we're going to talk a little bit more about these p-values later on. However, what I want you to know is that your analytics people are going to be talking about the p-value, and you're going to not know what that is. A low p-value means the variable is probably good and should be in the model. The other thing that you're going to want is up here, we have an Anova table. And the only thing you really care about at the Anova table is, again, the significance value, way over here. And this is a very low number again. In this case, it's 0. The reason why these numbers are 0 is because we have a perfect line. All of the variables fall directly on the line. So everything here is looking real nice. So the chances, this is a low number, and again, this is, you got to think of it the opposite way. But this is the significance of f is 0. And that will also be a probability value. And in this case, this is the probability that the model is really no good. And so there's a 0% chance that this is a bad model. Why? Well, everything falls directly on it. So this guy is a perfect model. And so there's no chance that's a bad model. And there's no chance that this intercept is no good. And there's no chance at all that that x variable is no good. Also, we come up here and we get an r squared value. This guy will give us an r squared value, and he'll also give us an adjusted r squared value. So these will be the only variables you really care about when your analytics people are talking about. You know, when they come to you and they say, well, the model is significant, what they mean is there's a low chance that the model's really bad. And if they say, well, my p-value is good, that means that low p-value, that means the variable is good. So this is a very quick overview on what is regression and what we're doing, and we did it with perfect data so you understand. In the next video, we're going to use some data that's not perfect. So that's it for now.